Hey, Mr. Dewick here. I just wanted to talk about a couple of the questions from Lesson 3. So these are ones a number of students have asked me about already. So Lesson 3, number 4, looks like this. It says, find the acceleration of a 105 kilogram dragster if its tires have a coefficient of friction of 0.7. How are we going to do that? Well, as usual, this is a job for a free body diagram. And if we draw the free body diagram, get the obvious one, mg, normal force. Which way is this dragster accelerating? Let's assume forward is to the right, and so it's accelerating to the right, so there has to be an unbalanced force in that direction. The question is, what force is that? No, it's not F tires or F motor. It's the reason cars and dragsters can't drive well on ice. The force that makes a car go forwards, or a dragster, is friction, and there is no force pointing backwards. So for my equation, who's winning? Friction. Who's losing? Nobody. It's like elementary school sports day. Everyone's a winner. What's that going to equal? ma. Friction is mu times the normal force. I don't know the normal force. Oh, but look. I don't know the force the same size as the normal force. I can say mu mg equals ma. And what's kind of cool is actually the m cancels. They didn't need to give me the mass of the dragster. They did, gave it to me, but they didn't need to. Sorry for the cough in the microphone there. So the acceleration from any car, if you're maximizing its acceleration, this is what you can accelerate at before your car starts to skid, before your tires start to spin, is equal to mu g, which in this case is 0.8 times 9.8, and that is 7.84 meters per second squared. Number 5 is really similar, except in question 5, now we're coming to a stop. And it wants us to find the distance. Okay, I can do that. So here's number 5. Close that window. So if I want to find how far, it says before stopping, so VF equals 0. I guess VI is 3. You know what? If I knew the acceleration, I could then use VF squared equals VI squared plus 2AD. I can go D equals VF squared minus VI squared all over 2a, not 2d, Mr. Dewick. 2a. Oh, and since VF is 0, really it's just negative VI squared all over 2a. So if I can find acceleration, well, how can I find acceleration? I think this is a job for a free body diagram. What are the forces acting on this rollerblader? Gravity down, normal force up. And this rollerblader is coming to a stop. They are decelerating, so that means they're accelerating backwards. There has to be a force that way. What force is that? That's friction. Now, a lot of students want to say, Mr. Dewick, he's moving forward or she's moving forward. Doesn't there have to be a force pointing forwards? No, remember, Newton's laws tell us the direction of acceleration, not the direction of velocity. So this free body diagram will bring an object to a stop. And so, who's winning? Friction. Who's losing? ma. No one. What does winner minus loser always equal? ma. You know what? Number 6 is the same question as number 5, except number 6 wants to do wants me to do this algebraically. It wants me to prove that that's stopping distance. And you know what? I'm kind of close already. I'm going to do number 5 algebraically, and that will tackle number 6. And then I'll let you plug in the numbers for number 5 on your own. So friction equals ma. We would still have mu times the normal force equals ma. I don't know the normal force. We would still have mu mg equals ma. Again, the mass cancels, and again, we get the same acceleration equation for both speeding up and slowing down. We get a equals mu g. So I can plug that into this equation. I'll get stopping distance is negative vi squared all over 2 mu g. Now, because there's only one velocity, often we don't even bother putting an initial or a final. We just say, put the v that they're giving you into the equation. And you can see I'm almost the same, except I've got an extra negative kicking around on the top here. Why is that? Well, here we're slowing down. If I walked into my kinematics equation, I would have needed to stick an extra negative in to show that I was slowing down. I would have made that acceleration negative. And then I get a negative divided by a negative, which I'm pretty sure last I checked was positive. And I get that stopping distance when you're dragging yourself to a stop, whether it's using your car's brakes or whether it's dragging your rollerblader or whether using your bike tires, it's v squared divided by 2 mu g. By the way, since you're all getting your driver's licenses, the fact that this v is squared, here's what that means. If you're going twice as fast as the speed limit, it's going to take you 4 times further to stop because that v is going to get squared. If you're going 3 times faster than the speed limit, it's going to take you 9 times further to stop than you're used to. And I think I've just explained a substantial number of dumb traffic accidents when people are speeding. #NerdTrivia.